Alright, so this week we're going to take a look at section 6.1. Okay, we'll do section 6.1 today, tomorrow, Wednesday. Thursday we'll do some kind of review, bless you, maybe some bonus points on the test, kind of like we've done before if you get questions right. We'll figure it out. Alright, so first part, today's got a few different vocabulary words I'm just going to kind of go through. We'll let you know when you get to something important where that box is, you got to write it down. So, first thing, you might hear Mr. Roy and I use the word like a monomial, algebra 2, or even the second part of algebra 1, you're going to hear the term binomial a lot, or trinomial. Basically, if you look at the word nomial, does that kind of remind you of anything or sound like anything?
No, number?
Number, right? Number. So you think like number and mono. Does anyone know what that prefix means? Yeah?
One.
One, right? It means one. So, monomial has to do with one thing. Whether it's a number or a letter, it basically just has to do with at least one or more things. Right? So a monomial is any type of algebraic expression. Now when you think algebra, what's always involved when you do algebra?
Letters.
Letters. All right? So an algebraic expression is anything that has letters or numbers in it. Okay? So here's some examples of monomials. Okay, a monomial can be just a single number, all by itself. Technically, that's considered a monomial. It's the simplest kind of monomial you can have. It's just a number. All right? Letter, that's considered a monomial. All right? Now, it says here you can have either a constant, that's a number, a variable, that's a letter, we just did those, or a product of numbers and letters. Okay, like this one. That's a product of a number, 4, and a letter, x cubed. That letter actually has a power. Okay? That's a monomial. Right? Here's another monomial. 2 times x times y. It's the product of a constant. Constant here is 2, and 1, or in this case, more. 1 or more variables, 2xy. Okay? What operation don't you see in any of these? Like if you look at this one, this one, this one, or this one.
Addition.
Addition. You don't see addition or
Subtraction.
subtraction. Yeah, we could do division. Like I could put in like a fraction like that, 1/3 x. There's division. That's okay. What you can't have with any of these problems we're doing is addition or subtraction. Once you put in an addition sign, it's not that anymore. Okay. If I did something like this,
Yeah, it's not.
1, 2. There's 2 things. If you look at the plus sign, it's like a separator, right? 2 things wouldn't be mono. 2 things, think of like a bicycle. Bi means 2. That's a binomial, because now it has 2 things. So you're not going to see addition or subtraction, okay? Products, numbers, letters, okay? No addition or subtraction. That makes it a monomial. Any question on that? So how about that? Is that a monomial? C squared times D squared?
No.
Does it have addition in it?
No.
Does it have subtraction?
No.
Is it just letters and numbers? Or yeah, it's just letters and numbers. Well, in this case, it's just letters. That's a monomial. How about that one? Monomial?
Yeah.
Yeah. Just a product of letters and numbers. How about this one? M to the 4th, M to the 12th. Monomial? Yeah. There's no addition, there's no subtraction. It's just letters and numbers, right? So those are all monomials. All right, so on your sheet in that box, we already went through these 2 words in the warm-up, but you want to write them down. Okay. Whenever you have something with a number up higher, that number up higher has a name. Okay. It's called the exponent. Now, for this week, I think the exponent is always a number. The next week, we're going to look at what happens when the exponent is a variable. That's a little different. So both this week and next week, we're going to be looking at things that have exponents. But this week, it's always going to be numbers. Now, the thing that's lower, okay, you look at the number that's higher, that's your exponent. What was the other word somebody gave us? Power. You call it a power. The number or the thing, because it could be a letter, the thing that's lower than the power or the exponent is the base.
So nothing goes in the circle?
Yeah, you could put like in this case, if I was going to put this in this template right here, I'd put the x there and I'd put the 3 there.
Okay.
X cubed. So whatever's in the circle, that's your base.
I'm just showing you guys the difference. The big thing, whether it be a letter or a number, is always the base, and the little thing is always, for this case, is the exponent. And for this week, it's always going to be a number. We're not going to put a variable there.
Now, the one that I just circled, the x, no exponent. But everything has an exponent. It's not written.
It's just 1.
It's always 1, right?
Just like we said when we were doing like slope, we said any number, any whole number could be put over 1. We just don't do it every time. It's the same idea with this.
All right, so what we want to look at is actually kind of like the problems I was just showing you on the next page. Right? When you've got something like that, is there a way to take these two things and put them together? Right? Is there a way to take these two things and put them together? Well, the answer is it depends. Right? Here I'm looking at it, I see a C and a D. Here I'm looking at it and I only see one thing, I only see an R. Well, if you have something like that and you want to take everything and put it together, the bases have to be the same. Right? Anytime you want to do multiplication or division, you have to have the same base. Think of it as like combining like terms. If they're not the same base, they're not like terms. You can't put them together. Now, how do you put them together? We haven't said that yet. But if they are the same base, there's a way to do it.
Certain rules. So anything, as it says, to multiply, divide monomials, bases have to be the same. So on that first line below the box, that's what you want to write. And we'll get into like dividing them. We'll get into dividing them tomorrow. But it's the same. Anything we do with this stuff this week, the bases have to be the same. The rules will be a little bit different, but to be able to do whatever the rule says, the bases have to be the same, depending on what the problem looks like.
All right. So anytime you want to multiply or divide, those are the two things. We're not really talking about adding and subtracting, because that's we said that's binomials. We're not doing that. But multiplying and dividing, got to have the same bases. Here's an example of two things that have the same base. Okay, they both have the base a. Okay? A to the third, a to the fourth. You might say, well, they have different powers. That's okay. All right, they can have different exponents. But if I wanted to multiply these together, these are good to go. They got the same base. Okay. What's another way to say a to the third? I mean, you could say a to the third power. That's kind of the same thing. But
A to the third exponent? No.
it's kind of the same. There's actually another word you can say if it's raised to the third or to the second. These are the only ones that have special names if you want to use them. Yep.
A cubed?
You can say a cubed, right? So a to the third. If you hear a cubed, same thing. And then how about if it's like to the second?
A squared.
A squared. So those are the only ones that have special names. If it's like a to the fifth, you just say a to the fifth. Or a to the fifth power. There's no special word. All right, so let's look at an example of how we would find a cubed and a to the fourth. And we're going to do this one out the long way. We're not going to do them all out the long way, because there's a shortcut, there's a rule. But I think if we do it one time,
So you can see it.
you'll see the pattern. And then we'll just make a rule from that. All right? So let's start with a cubed. What does a cubed mean? Like if you were going to write that out for somebody that didn't understand having an exponent, what would you tell them to write?
A times A times
A times A times A. So you'd start with that. Right? A times A times A. Times, okay, because we're multiplying, we're finding the product. What would be the next thing? Yep.
A, and then times A 4 times again.
Yep. Times A 4 more times. A times A times A times A. All right. So now let's look at what we've got here. We've got A times A times A times A times A times A. So let's look at, put that back the way it was. Or not. There we go. So to multiply that out, does anyone think they know a short way you could write that? Like, yep, A what?
I can combine all of those 7.
Yeah, A to the
7.
7th power. A to the 7th power. That's what this means. because you have a times a 7 times. So we took it, we wrote it out the long way, and we saw, wait, you're just multiplying the same thing 7 times, you've got a shortcut for that, we just use a power of 7. So what do you think the rule is if you wanted to multiply these two things together?
Hey, Yusuf, you said a to the 7. How did you figure that out?
I just 1, 3.
Yeah, all you have to do, if you're multiplying things with the same base, is take your two exponents. I don't know why I keep doing that. Take your two exponents and just add them together. That's it, right?
But the bases have to be the same. Like I said, like we said in the beginning here, those bases can be numbers too. So keep them, if it's, say if it's 2, if it was like 2 to the 3rd times 2 to the 4th, it would still be 2 to the 7th. It would still add up the exponents.
All right, so to multiply powers, and again, this only applies if they have the same base. I already said that. Okay. Let's see, what I'll do is I will write it out. I'm going to write it 2 ways.
It might be on the next page too, Mr.
That's what I looked, it's not there.
Oh, I didn't get
Maybe
the
a page after that, I don't know.
Maybe we got it,
Probably has.
maybe it's at the bottom.
Go one more slide.
Now we're getting into other stuff.
Alright.
All right, so to multiply powers if they have the same base. All right. So what you want to do is add the exponents and keep the base the same. Keep the base the same.
So keep the big number or letter the same, then add the little numbers together.
Let's say I had something like a to the x times a to the y. If you look at those, do those have the same base? What is it? Okay, yeah, they have the same base. So to multiply, if they have the same base, yep, they do, add the exponents. What's the exponent on the first day? What's the exponent on the second A? And what do you do with them? Add them. So the new exponent is going to be what plus what? There you go. What's the base going to be? Keep the base the same. So A to the x plus y. Now, what are x and y? I don't know. Whatever they are on the phone.
We're showing you a rule that would work for any number that you put there.
So as long as the bases are the same, just take the first exponent, second exponent, add them up, and there's your answer. Now, if they have different bases, you don't do anything. If they say what simplify and the bases are different, just write the same problem over again.
Yeah.
Okay.
I mean, you wouldn't write it with a little like multiplication dot. You just write the 2 things that were there.
Basically, anytime you write your final answer, there should only be one. You shouldn't have 2 letters that are the same. If you write a final answer like, let's say you had letters like this, a cubed times b squared times a to the 4th. That's not right. It can't be, right? Because I can see the same letter in different spots. If you've got the same letter in different spots, you haven't combined everything you could, right? If you had something like this, that could definitely be a final answer. Because I don't see the same letter in different spots. Okay? I see a B here, I see an A here, but they're different. I can't combine them. Okay? So you should only have one of each letter in the final answer. Okay, so first example. R to the 7th times R. We've already told you, but we're not going to tell you this, okay, on problems from now on. If you don't see an exponent, just put a 1. And that 1 is important because it's going to be part of the final answer. Okay, so first question. Simplify if possible. Can this be simplified?
So guys, on your notes, you should be writing this under example 1A. We'll get that. We'll do problems like that in a second. Good question. And if you want to write no exponent or a power, put a 1, you can. You don't have to. If you're going to remember that, you don't need to write it.
So in example 1A, can those be simplified?
Yeah.
Why?
Because they had the same base, whatever.
Yeah, because they already have they already get the same base, all right? So now we need to follow the rule. When they have the same base, what do you do to the base?
Keep it the same.
Keep it the same. So all you're going to do here is put an R. Now, how do you get the new exponent?
Just add 7, and then if there's a 1, just add
Yeah, that's why we put the 1, so we remember to add it. What's my exponent going to be? R to the 8th. Perfect. That's your answer. Any question on how we got R to the 8th? All right, let's look at 1B. Simplify if possible. Okay, first question you ask yourself. Can that be simplified? No, why not?
because they have different bases.
They have different bases, but the 2 and the 2 are the same.
Doesn't matter.
Doesn't matter, those are the exponents, right? We don't need the exponents the same, we need the base the same. So all we can do here is pretty much just write c squared, d squared. If you put the dot between it, it means the same thing. If you don't put the dot, it doesn't matter. So nothing you can simplify. And I'll just write y. So bases are not the same. That's why. All right. How about this one? Can we simplify that? Jacob, what do you think? No? How come?
Not the same.
Not the same base, right? This is an x, this is a y. They're different. So what's the answer here? It's just whatever you started with. Now, if I threw something in front of that, like if I put this in front, now you can simplify a little bit. There is something you could do now, at least with the x's. There's nothing you could do with the y, right? But we'll
Same thing, say if the x had, like, say if it was 2x to the 4th and 3y to the 6th. You could still multiply like the 2 and the 3 together to get 6. They were whole numbers.
Yeah, I think we're going to get to those, yeah.
That's what I'm saying.
Yep.
Another question, is it okay if, like, you know, the x to the 4th, like, is it okay if you leave it, like, blank? You don't need to, like, transition
The sign, right?
yeah, the multiplication sign, you know what I mean? Like,
The dot, the multiplication.
Yeah, your final answer, you have to put that.
You don't have to put the dot. If you do put the dot, it's okay. If
Yeah,
you
we'd
don't,
rather you wouldn't, but if you do, it's okay.
That's my question.
yeah, the dot can look confusing, especially if you have a number with a decimal in it and you got dots and decimals. It looks kind of weird. How about this one?
Yes.
All right, what can we do here?
You can take this one.
You can't add them.
All right, what are we looking for?
What,
Same base. Do we have the same base?
Yeah.
Yes, we do. A. So what's the base going to be in the final answer?
A.
It stays the same.
That's just what we added.
But what do we do with the exponents? Yep.
Combine.
How do you combine them? Like Joe, you just said it.
Add them.
Add them.
Thanks, Joe.
What's 2 plus 3?
5.
5. Now, on this one, I'm going to show you something. 1E is kind of like 1D, but I'm going to show you something that Mr. Roy kind of said, but we're going to get to more of them.
if there's a multiplication sign in between the two exponents, why do we add them?
Because the rule, like if you did this out, count how many you would have. You'd have A times A, another A, another A, another A, 1, 2, 3, 4. You have 5 of them, you don't have 6 of them. There is a rule when you multiply the exponents,
Yeah.
but that's different.
Okay.
There is a time when you have to multiply. So what happens is once you know all these rules, the rules are pretty simple, but you got to keep track of which one you use when.
Apply.
Yeah.
You may have 3 rules on one problem.
Now, let's look at this one. What number is in front of m, like the m to the 4th?
Nothing.
Well, there's always something there, right? It's a 1. Every problem we've done so far, this number has been a 1. I haven't written it in because we don't need it, right? This was a 1, this was a 1. This was a 1, this was a 1. I mean, I go through all of them. 1, they've all had 1s in front of them.
You just didn't write it.
How about in front of the m right here? 1. So if I read this problem out, okay, what it really says is 1 times m to the 4th times 1 times m to the 12th. Okay? So you're really multiplying 4 things there. It's just the 1s don't really matter. 1 times m to the 4th times 1 times m to the 12th. So eventually what we're going to want to do is kind of think of it as like terms. Right? If you're multiplying 4 things together, does the order matter? Like if I did something like 2 times 3 times 4, 4 times 3 times 2. Does changing the order matter?
No.
No. So there's one thing, two things, three things, four things. And they're in the order 1m, 1m. Well, I'm going to put them in this order. 1 times 1, I just did those two. And then m to the 4th times m to the 12th. Is that the same problem?
Yeah.
Yeah. I have 1, 2, 3, 4 things all being multiplied. 1, 2, 3, 4 things all being multiplied. I just decided to put the ones in front. Now the reason I did that is because this number might not always be a 1. Maybe it'll be a 3. Maybe it'll be a 5. Right? And if it's a number other than a 1, like Mr. Roy just said, you can do this out. Now, in our problem, when we do it out, what's 1 times 1? It doesn't make a difference. It was just 1. Right? Now, if this was a 1 and this was a 3, we would have 1 times 3, and we would have put a 3 here. Right? But so far, it's always been a 1. So when we get to a problem like this one, we're going to do what I just said. Right? You got a negative 5, you got a negative 1. We're going to put those two numbers in front, here and here. Put like terms together. All right? All right, so we did that. 1 times 1, big deal. We didn't get anything there. What about m to the 4th times m to the 12th? M to the 16th. Now, 1m to the 16th is the same as what? You could just write m to the 16th. Okay? These two numbers in front, they did not make a difference in anything in example 1. But they're going to in example 2. Whatever it is. Okay? So questions on that rule? All right. So when you get something like this, okay, now you've got a lot going on. You've got 6 things. 1, 2, 3, 4, 5, 6 things you're multiplying together. And they're all mixed. Number, letter, letter, number, letter, letter. We don't want to mix numbers and letters. We want all numbers, numbers, numbers together. Letters, letters, letters together. Right?
You guys, you don't have to write this one down. I'm just showing you what it looks like, how to break it down.
So, somebody tell me what's the number. You know what I'll do? I'll circle them in color so you can see them. What's the number in the first set of parentheses? Negative 3. What's the number in the second set of parentheses? 7. You can multiply those together. We're just going to change the order because the order does not matter when you're multiplying. So we're going to put those two next to each other. So we got that, we got that. Is there anything else there that are like terms? Like something that's in the first parenthesis, something that's in the second parenthesis, and that I can put next to each other? The C's, right? C squared. There you go. C. There you go. And the D's. D. There you go. D cubed. There you go. That's the exact same problem. 1, 2, 3, 4, 5, 6 things all multiplied together. 1, 2, 3, 4, 5, 6 things all multiplied together. It's just we put them in a different order. So we put the numbers next to each other. We put C's next to each other. We put the D's next to each other. We just kind of regrouped it so like terms were next to each other.
And guys, when you do this, you don't have to regroup it every time. They're just showing you what it looks like, how you can break it down.
Any question?
And guys, with this, sometimes what I do is when I'm doing these, I think of the whole numbers, so the negative 3 and the 7, the whole numbers, and then the different letters, A, B, X, Y, whatever. They're all separate. So what I do is, and you can rewrite it like this if you want. If that works for you, that's fine. What I'll do is I'll draw lines. I'll put big long lines to separate everything. So I know that the negative 3, because the negative 3 and the C squared, we're not treating those as, they're not together. They're separate things. To be able to do this, we have to treat, when we do this stuff this week, we have to treat whole numbers separate from letters, right? And if a variable or a letter or a number has an exponent, you have to treat, this is a package deal. Like the C with the squared, that's together. They stay together. Kind of like when we say the sign to the left goes with a number. We know that negative goes with a 3. We know that this 2 goes with the C. We know that this 3 goes with the D. Whatever exponent is to the right belongs to that letter or that number. So you can break it down like this too if you want. It's up to you. Do a couple if you want to. All right. So same thing again. You can group them together like Mr. Hager did. All right. So this is going to be example 2A on your notes. Like Mr. Hager said, you can go through it and rewrite it and group it all together. That's entirely up to you. I don't think you need to. I think if you draw the lines, it's a little bit quicker, and it's going to accomplish the same thing, and it's going to save you guys some writing. So you're on the back side of your notes now, top left corner, that's where example 2A is going to go. So we got negative 5x to the second y times negative xz to the third, or cubed. Now what I would do first here is, I could put something with the y in this set of parentheses, and with the x in this set of parentheses. What can I put with the y and the x?
A 1.
A 1, right? Because there's no exponent there, but we can write any number we want. It's always to the first power. We just don't do it every time. Just like any whole number, when we talked about slope a few weeks ago, any whole number could be written over 1. Like we said, if I have, say if my slope was like 2x, that 2, it's like an imaginary 1. We know it's over 1. All right? So like you guys said, put a 1 to the right of the x, put a 1 to the right of the y. Is there anything else I can put in this set of parentheses? There's a negative sign there, right? Is there a number attached to that negative?
Well, for the first one it's 5, but
Yeah.
the second one it could be 1.
It's 1. It's not could be. It's definitely going to be. All right. So I'm going to put a 1 here, just so I know. All right. Now I'm going to draw my lines. Again, I draw them long enough so I know I don't confuse them for a 1. All right. So I know, again, the whole numbers are separate from one another, and the different letters are separate from one another. And if they have an exponent to the right, that exponent belongs to the base on the left. This 2 belongs to that x. That 1 belongs to that y. That 1 belongs to that x. That 3 belongs to that 7. That z, I should say.
It looks like a 2, honestly, but...
This is a z. That's why Mr. Hager puts the line through it so you know the difference. Right? So all those things are separate from one another. Alright? What's one set that we can multiply together? I could do the x's, yeah. And when I multiply the x's, what am I going to get?
X to the third?
X to the third, right? Again, if the bases are the same, keep the base, x, add the numbers. 3. So now I've taken care of that. The x's are done now. Bases were the same. I kept the base as x. I added the little numbers, and I got 3. Anything else that might be the same? Ellie?
-5 and -1.
And when I multiply them, what do I get? Negative times a negative?
6?
No, I'm not. Remember now. Don't make a good point. Don't confuse the rule. When I have whole numbers like this, I'm going to multiply them like normal. -5 times -1. There's no special rule for that. You multiply those numbers together like you normally would. -5 times -1 will be +5. There's no special rule for that. Multiply the whole numbers together like you normally would. They don't change. Alright? So I've handled that, I've handled this, I've handled the x, I've handled the x. What else do I need to write in my answer?
X to the third.
So the x's are done, I already have down in x to the third.
And then y to the 1.
Y. I'm just gonna put y, I'm just gonna put y, I'm not gonna put it to the first.
And then z
Forget
to
z.
3.
Z to the what?
Very fast.
Good. Remember, look at the directions. Simplify. Simplify means go as far as you can. You may not get a nice one number answer, like x equals 2. There might be, like in this case, there's more than one thing. We got the 5, we get the x's, we get the y's, we get the z's. Right? When you do this, guys, when you write your answer, my suggestion would be try to write it in alphabetical order. Don't put like the z first. You're not going to be wrong, but it's just easier for us to read it. It makes more sense when you try to go in alphabetical order when you write your numbers. I'm sorry, when you write your letters. All right? So again, we're treating everything separate from one another. All right? But again, if I'm multiplying whole numbers, just multiply them together. I'm not adding them. I'm only going to add the exponents if the bases are the same. All right? So that's a little more involved. But again, we're going to do something in a little bit where we're also going to be dealing with parentheses, but there'll be a different rule. All right?
Another rule.
This one. All right. Oops. So this here has no parentheses. This does. It doesn't matter.
Doesn't make any sense.
We're still gonna multiply it together. We're still gonna multiply these two things together. If I have whole numbers, just multiply the whole numbers together like you normally would.
So you divide 3 times.
It's not dividing.
I mean, you do 3 times -2, right?
Yeah, I do 3 times. So again, those are separate. This is separate. This is separate. This is separate. That's separate. Guys, if you don't draw the lines, if you can just see it and know which things are separate from one another, that's fine. If this is confusing you, you don't have to do it.
A lot of stuff going on there.
There's a lot of stuff going on here, right? But again, if you don't want to draw the lines, that's fine. I think for me personally, to keep it organized and be able to see it, that's fine. If it's more stuff on paper that confuses you and you can't do it, you don't want to do it, that's fine. I'm just giving you this a suggestion. Like Campbell just said, we're doing 3 times -2, we're going to get -6. So we took care of this, we took care of that. If I'm going in alphabetical order, all right, A is the first thing. I got A to the 5th. Do I have anything else? Do I have anything else with A as a base?
No.
No, what am I gonna write?
It's
A to the 5th.
Nice.
That's done. And if you don't want to check them off, you don't have to. I'm just showing you how we're going through each thing. All right? Now I got my B's. What am I going to get, Nicole? B to the 7th, right? Keep the base, which was B. Add the numbers. 4 and 3, 7. Use that, use that.
So then it would be like C to the 8th power?
Not C to the 8th. C to the 9th, right? Because we have to put a 1. We don't have to put a 1 there, but we have to know that there's a 1 there. So C to the 1st, C to the 8th, C to the 9th.
Where's the other C? Also there.
That's my final answer. Yep. C to the 1st right here, C to the 8th right there. Again, I multiplied the whole numbers. That's why I got -6. A to the 5th, there was nothing else with A as a base, so I kept it.
You want a laugh shot?
I got my B, C to the 7th, then I got my C to the 9th. Done. Final answer. Take it.
I had a window, so.
Good?
Yo.
Got this.
What the-
Alright. So guys, the first thing that's written up here, listen, the first thing that's written up here, we already talked about. To multiply powers with the same base, you add the exponents and keep the base the same. You don't have to write that, you already did. Alright? So understand, whether there's Yusuf, whether there's a dot,
Same thing.
whether there's a dot between the two things, or parentheses, you're going to keep the base, add the exponents. If there's whole numbers, multiply the whole numbers together like normal. Alright? Okay, so we already talked about that rule. Now, suppose we talked about a monomial, a to the 3rd raised to the 4th power. notice how it's written. Notice how it's written differently. We have the power of 3 on the inside and the power of 4 to the outside.
Oh, there's like two powers.
So,
Try to finesse.
what this means is, if I was going to write this out, guys, let's see if you have that here. Okay. So if I have this means a to the third times a to the third times a to the third times a to the third. It's a to the third multiplied together 4 times. So 3, 6, 9, 12. A to the 12th.
Could you just do?
Oh, I see what we had to do there.
Donovan just said it. Perfect. He goes, Mr. Roy, couldn't I just do 3 times 4? Yes.
Yes, that's
All right? So that's going to bring us to our rule. So again, this is basically what Donovan just said. All right? To raise a power to a power, you multiply the exponents and keep the base the same. So listen, when we multiplied exponents, the base had to be the same, and we added the numbers. But it's different when the number's written to the outside like this, when there's an exponent written outside the parentheses on the right-hand side, you're just going to multiply. Right? When there's no exponent on the outside of the parentheses, add them together like normal. What this rule is called, guys, is power to a power. You're taking the power that's already there, like we did here, and then raising it again. All right? So understand the difference. No parentheses, just keep the base, add the numbers. When you have parentheses, multiply the exponents.
Boom.
All right? So understand the difference. All right? Everybody has this?
Yeah.
So those are the 2 rules we want to talk about today. Now again, when we're doing when we have to add the exponents, when we have to multiply them like this, you may get, we're going to talk about tomorrow when you have to divide. You may get, we're going to add another rule tomorrow. You may get all 3 rules in one problem. But again, we're going to kind of give you some steps to look for when you do a problem like that. All right? So here, it wants us just to simplify.
It's easy.
Mr. Roy,
Yo,
can you go back?
sorry, yeah. Okay. Okay, there we go.
We have to wait.
But again, guys, when we're dealing with this stuff, the bases always have to be the same. Whether we're multiplying, like we did in the first couple examples. Whether we're doing power to a power, like we're talking about now. Whether we're doing division, like we're talking about tomorrow. The bases always have to be the same. And again, if there's whole numbers, whether we're doing multiplication, just multiply the numbers like normal. That doesn't change. If you're dividing, like we'll do tomorrow, just divide the numbers like normal. The arithmetic for that piece doesn't change. Right? That stays the same. Alright, so power to power, again, keep the base, multiply the numbers. I think of it almost like as the backwards, like distributive property. I have the 4, I'm multiplying it times the 3. Keep the base. Nicole, good now? Everybody's good with this?
Yep.
So this one, I got c to the 2nd raised to the 5th power.
C10.
C10.
C to the 10. That's all it is. C to the 10th. Again, 2 times 5, all right, is 10. Now, if we had more than one thing on the inside, let's say, I don't know, did we get one like that?
We have an extra rule, yeah.
Okay.
One more rule.
Sorry, I'm saying.
It's okay.
All right, so it's C to the 10th. All right? How about Dylan?
Damn.
What am I going to get for this one?
One more stop.
Y to the 3rd raised to the 10th power. So up here, we did 2 times 5 and we got 10, right? So what's this one going to be?
30.
30, right? Again, all we're doing is just and again, for this rule, guys, it doesn't really matter what the bases are. The bases can be different because we're just going to multiply that number each time. All right? It'll make a little more sense when we do these next ones. All right? So suppose we take a product such as 2x and raise it to the third power. Alright? So like this. It's called power of a product. So I'll show you how it works. You don't have to worry about writing this down. So it's 2x to the third. Remember, whole numbers in different letters are always separate. So there's a line, or the 2 and the x are separate from one another. You have to treat them separately. What exponent goes with the 2? To the 1. And then x is to the first power. I'm going to take this 3 and multiply it in to each exponent that's inside. I'm going to take it and multiply it by the 1 that goes with the 2. I'm going to take it and multiply it with the 1 that's also with the x. Again, the bases do not change. So inside the parentheses, what are my bases? What are my bases inside the parentheses?
Ones.
No, those are my exponents. X is one of them.
And 2.
And 2. Those don't change. The only thing that's going to change when I do power, when I do this power to a power, the only thing that's going to change is the exponents. So what exponent now is going to be with the 2? It's going to be 2 to the what? Remember, I'm multiplying now, right? So it's going to be 2 to the what? 2 to the 3? Or 2 to the third? How about the x? X to the third. Again, keep the base. That's why I wrote 2. That's why I wrote the 2x right away before I did anything else, because that's not going to change. The only thing that's changing is the exponents. Again, even though it's not written there, any number or variable that doesn't have an exponent written is always to the first power. So I'm just gonna. That's why I just took and put a 1 there and I put a 1 there. Treat them separately. 3 times 1, 3. 3 times 1, 3. Mr. Hager, do you want to simplify? Okay. So if we have a whole number that has an exponent, we have to simplify it. We can't just leave it as 2 to the third, because we can take that a little bit further. We can make that a whole number with no variable. So 2 to the third is going to be simplified to what number? 8. How'd you get it, Nicole? 2 times 2 is 4, times 2 again is 8. There's your final answer. All right? If you write this, you would be wrong. Remember, it's not 2 times 3. A lot of people make that mistake. All right? It's this number multiplied together that many times. It's the base multiplied together that many times. Like Nicole said, 2 times 2 times 2, 2 times 2, 4, times 2 again, 8. It's not 2 times 3. Don't make that mistake. All right? So that's again, we have more than one thing inside the parentheses with an exponent on the outside. That's how that works. All right? I think that might. Is that all of them, guys? Okay. All right. So this one, again, I have numbers and letters on the inside of the parentheses, but they have no exponents. Garrett, what should I write for exponents on the inside of the parentheses?
1.
Yeah, the negative 4 is going to get a 1, and the c is going to get a 1. So I'm going to rewrite it down here. Negative 4 to the first, c to the first. Now, if you, like I said, when I separate them, when I draw my lines, you don't have to do that. That doesn't make sense for you, that's fine. If you know that there's a 1 attached to each different number in each different letter, that's fine too. Me, I'm going to write the ones that way I don't forget. All right? So Nathan, negative 4, right? It's going to be negative 4 to what power? To the third, right? We're multiplying the exponents. Power to a power. Negative 4 to the third. All right? Melanie.
No, I was just gonna answer.
Melanie, what about this? What about the C? C to the what?
What?
C to what power? So I got, when I had the 3 on the outside, I got negative 4 to the third. How about my c?
C to the third?
C to the third, I'm just multiplying. Wait, Mr. Hager. Alright, now, when you have, again, this -4 is the base, right? It's the big number. It could be a letter too. When the base is negative, when you have a negative base, it could be -x, it could be, in this case, -4. When you have a negative base and an odd, the number 3, right, is an odd number. So when you have a negative base and an odd amount of exponents, your answer is always going to be negative.
I think you should use a calculator.
Yeah, I'm just telling you that there is a pattern. So if you have a negative base and an odd amount of exponents, your answer is going to be negative. If you have a negative base and an even amount of exponents, 2 to the second power, to the fourth power, to the sixth power, your answer is going to be positive. That's just a little, just to check yourself. Like Mr. Hager said, it's fine. You can use a calculator for this.
But you can't type it in the way it's written on the
Yes.
What would you have to do? We talked about that in the warm-up. Well, actually, it's right on the board, right there, right on the calculator.
It's a long,
The carrot.
We talked about it right there.
You gotta make sure when you type it in your calculator, even though it doesn't have it there, you gotta make sure you put it in parentheses. If you have a negative number as the base, and you wanna apply the exponents, you gotta make sure you put it in parentheses.
Yeah, when you rewrite it, always put parentheses around that -4. Any number that has a negative, because the negative is always with the number. It's like a package deal, so you put parentheses around it. With a positive, you don't have to worry. There is nothing to put with it.
So like for C, it's going to do anything.
For C, you don't need parentheses, because there's no negative with it. Nope.
So I'm gonna do my parenthesis, and I'm gonna do what, -4? Again, not the minus sign, a negative has a little parentheses around it. So -4, the little caret button right here, that's your exponent button.
It's the same button on my calculator too, I think.
Yeah,
Same thing.
it looks the same, the one you guys use looks the same way. So we get -64, like we said. We have a negative base, odd amount of exponents, your answer is going to be negative. All right? So we're going to get -64, C3. All right? There's nothing I can do with the C's. Again,
Now, if you forgot parentheses on this one, you'd get lucky. It would still come out right. But it would only come out right half the time. And Mr. Roy kind of explained the pattern of when it would, when it would work and when it wouldn't. So just, if you have a negative number, always put it in parentheses.
Yeah.
Just do that.
for the sake of applying an exponent, when you're putting an exponent with it, make sure you put it in parentheses. Or every time.
Right. I will tell you, this time if you forgot them, you would have been okay.
Yeah. And again, when you have a whole number with parentheses, make sure you simplify it. Right? Don't leave it like this, -4 to the third. You can simplify that. You can take that one step further. With variables or the letters, it doesn't matter. You can't do any more than that. C to the third is C to the third. You can't break that down anymore. But not when you have a whole number with an exponent, you can break that down slowly. So just make sure you simplify it. Alright? One more. I should get 2 more. Okay.
2 more?
Oh, a lot more. Okay. It's okay.
What can you do?
Yeah. So this one, same deal. I'm gonna. Now remember, I get that negative sign, right? That means I'm gonna put a 1 here, so I don't forget. All right? It'll be -1 to the 1, x to the 1. Again, whenever I have numbers or letters that don't have an exponent, put it to the first power. That way you won't forget to do it. Right now, that way you won't forget to simplify. You won't forget to simplify it when you need to. All right. So my -1. I drew my lines, so you can see I'm applying that 4 to each thing. So I'm gonna get -1 to what power? -1 to the 4th power.
How should you write it?
And Mr. Hager said, make sure when you have a negative, make sure you put in parentheses.
This time, if you forgot them, it would be wrong.
Bethany, what about my x? Gonna be x to the what? X to what power? Yeah, so I'm multiplying, right? Now, if it was like this, if it was x to the 1st times x to the 3rd, then I get x to the 4th. So I'd be adding in that case. In this case, I'm multiplying. All right? Nice job, x to the 4th. How about, Matt, how about my y's? Y to the what? Don't say 6. So y will stay.
And then you would put the 2.
Okay, so Bethany got x to the 4th by doing 4 times 1. So what's the exponent going to be with my y? 8. 4 times 2, not 6. We're not adding them, we're multiplying. All right, one more thing we got to do. Let's go to our calculator. We're going to go parentheses, -1, end parentheses, caret button to the 4th, right guys? 1. All right? So this right here, it becomes positive. So it doesn't really matter. I don't need it anymore. I don't have to put 1 x to the 4th, y to the 8th. I don't even need it. Doesn't matter. I don't need it. My final answer would be x to the 4th, y to the 8th. I mean, if you put the 1 there, you're not wrong, but you don't need it. All right, guys. For the sake of time, we're gonna skip. We'll skip the rest of it. All right. So as you're packing up, just listen. Homework is a worksheet. All the stuff we dealt with today will be on there. This is an old thing. You want some? Okay. Don't worry about this.
Oh, is that for?
Didn't change it from last year. So like I said, guys, we'll have a review day on Thursday. Again, this is our second to last full week. Next academic week will be a full week, but then the 2 after that we have an MCAS, and the week after that we're in June, we're on final exams.
I can't believe
So we're getting
that
there.
out of school.